Yes, hello everyone. Welcome to Easy Science International. This is your tutor Ivan Serunjoji, and basically today we are looking at the isomerism. Before, I'm sure by this time you very well know the definition of isomerism. Uh, Basically, this is the existence of a compound with basically two or more compounds with the same molecular formula but different structure formulae. Basically that. So today we want to look at this phenomenon in carbonyl compounds. Well, looking at the isomerism in the carbonyl compounds, before we know that carbonyl compounds are aldehydes and ketones. So both aldehydes and ketones will exhibit what we call structural and functional isomerism. Yes. Well, we shall first look at the functional isomerism under the carbonyl compounds. Well, for functional isomerism, it is seen that both aldehydes and ketones are isomeric within themselves and with other classes of organic compounds like alcohols and cyclic ethers. So by so it means that well, we very well know that in the carbonyl compounds, we find there oxygen. Now, any other organic class of organic compounds that contains oxygen, a single oxygen atom, that can be that can lead to what we call functional isomerism. Basically, with functional isomerism, the difference is within the functional group, basically. So an example we can look at this is maybe when we have a compound with C4H8O. This is one molecular formula, C4H8O. That is basically having one oxygen, 4 carbon atoms, and 8 hydrogen atoms. So this compound can be an aldehyde. How? When you look at CH3CH2, CH with a double bond O. This is butanal, which is an aldehyde. The same, you look at the number of carbon atoms here are 1, 2, 3, 4. 1 oxygen and 8 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. Butanal. Now, so looking at this, it has basically 8 hydrogen atoms when you can look at that. On top of the 4 carbon atoms, 1, 2, 3, 4, 5, 6, 7, 8. Then it has 1 hydrogen like this and 4 carbon atoms. So it is butan 2-on, qualifying it to be a ketone. We are going to look at another scenario when we have cyclic compounds like a cyclic alcohol and a cyclic ether of the same molecular formula in our next tutorial. So basically that is functional isomerism under the carbonyl compound. So we've said that both aldehydes and ketones exhibit what we call structural and functional isomerism. So for the first segment, we've looked at functional isomerism, and we've seen that both aldehydes and ketones are isomeric within themselves and other classes of organic compounds. We've looked at we are actually about to look at the alcohols and cyclic ethers. So an example so far we've looked at is C4H8O. That is the molecular formula, and we've extracted 2 structure formulae. One leading to a butanal, which is an aldehyde, and the second leading to butan 2-on, which is a ketone. So let us look at another example, or actually 2 other examples where we have the alcohols and the cyclic ethers from actually the same molecular formula. So these are 2 isomers of the same compound of the same actually molecular formula from this. Yes, so thank you for listening and watching. Let us tune in to another tutorial.